don't have them before.
No, we have two homeworks. Simple circuits and resistivity, both on Friday. Yeah. This is the circuits, and this is resistivity. Okay. Yeah.
So number 4.
Yeah.
Where is the 04?
Huh? Where's the what?
Number 4.
Yeah, number 4.
The question.
Yeah.
It was 04.
04, 04. What do you mean? I'll have to look at it. There's a problem with it? Let's have a look anyways. Okay. We'll start with the resistivity was the first class we did, and then the simple circuits, wasn't it? Okay. I don't know if I have the questions here. I don't think I do. Yeah, well I have them actually, I just have them saved here. Resistivity, the last page. Okay. How was the first homework?
Easy.
Not too difficult?
Only the fifth question, the simple circuits.
The last question, yes. Let's have a look.
Last question.
Right, the first question is the nickel coin, 15 millimeters wide and 2 millimeters thick.
Which question is?
The first one on resistivity. So you had your coin like this, circle as a thickness. What did I say the diameter was? I think it was 15 millimeters, and the thickness 2 millimeters, yeah? So the resistance is equal to this. That's 2 times 10 to the minus 3. This is pi or squared. And then I don't have the constant here. What was the constant for nickel?
6.99.
Yeah.
Into 10 power minus
Minus 8. Okay, so what is the answer here?
7.91 into 10 power minus 7.
Did anyone else get that?
Yeah.
KJ, what did you get? The same, was it? 7.91 times 10 to 10 to the minus 7 ohms. Did you get that, Amanda? What was the mistake?
Pi.
You forgot pi? Okay. Grace, did you get this? What was the mistake?
A.
You forgot A or wrong?
A. R.
2.
2. I choose 2, not 15.
Ah, you choose 2, not 15. Okay, alright. Okay, can I go on to the next one now? Yep. The next one was with the pencil, yeah. Can I go down? Now I actually do this in class. I can do it in class for you, but if you have a piece of paper and if you take your pencil and draw a thick line on the page with your pencil, you can actually run a current through it. Because remember what's inside your pencil? Carbon, graphite. And this is actually a good conductor. So you can actually do this with a piece of paper and a pencil. You can draw a line on the page and you can actually run a current through it. It does actually happen. So the student does this and they measure 0.5 ohms of resistance. What else do I tell you? I tell you it's 10 centimeters. So if we look really here,
You need to find the width of the.
yeah, isn't that it?
Yeah.
Okay. Whoops. Okay. Now, if you look really closely at the pencil, if I look at the side, if I zoom in,
It's a rectangle.
I'll draw it, I'll exaggerate it, but it looks like this.
This looks like a rectangle.
This is like the, yeah, it looks, this is like, not the ink, the carbon on the page. If you're looking at the side, it looks like this.
Excuse me?
Yeah.
Is 10 centimeter for all the paper?
10 centimeter is the length of the pencil.
Yeah, that's
Yeah. Yeah. Okay. Now, you can't, with this question here, you can't really say it's a circle, because if you think about it, when you run your pencil on the page, it doesn't fill the paper like this. You know, if I do this, the carbon here, it doesn't look like a circle. It'd be at least a square shape. Yeah. Although we don't know for certain the exact shape, but it'd probably be more like a square than it would be like a circle. Okay, but like I said, we don't know, so we'll just assume it's a square. So I didn't tell you this in the question because I wanted to see what shape you would make. So how many people drew it as a square and how many drew it as a circle?
Rectangle.
A rectangle, yeah. Anyone do circle? You did circle, yeah. Now, in fact, even if you did circle, your answer will still be pretty close. So don't even worry if you did a circle, that's fine. It'll still be about the same, okay? Let's see what happens if you do square. I'll call it x and x. So I have r equals rho L A. Sorry, rho L over A. 0.5 equals 0.10 over x squared. I don't have the row for
It's
carbon.
5
Yeah.
into 10 minus 6.
Okay, so x should roughly be equal to square root 5 times 10 to the minus 6 times 0.10 all over 0.5. Now if you use the circle, which is fine, it's fine if you use the circle, then the only difference would be in your one, here you would have this formula instead. If you did or, you'd have or roughly equal to 5 times 10 to the minus 6 times 0.10 all over 0.5 pi. So Fahad, do you have it if it was an x?
You will get 1 into 10 minus 3.
1 times
The first one, yeah.
1 times 10 to the,
Minus 3.
so in other words 1 millimeter. 1 millimeter. And then what do you get if you do it using a circle?
0.56.
Now, that's 0.56, but that's for or. So if you wanted to know the thickness, you would have to use 2 or. So x equals this. And then 2 or would equal, what did you say 1 or was? 0.56? 1.12.
5.6.
No, 10, your power would be different. Yeah, you're 10 to the minus 4. I'm talking millimeters.
But it's 1, you know, then it's starting with 5.
Yeah, but I just said that's for or, and if we want the thickness, that's 2 or, so multiplied by 2.
Why did you use 2R?
Oh my goodness!
It's the diameter.
Yeah, because it's
I've said it! Alright, listen! Okay, look. answer is 2r. And if you use a square, the answer is x.
Okay.
And you can see I know there's a small difference. There's not a big difference. But I feel like the square is probably more accurate than the circle for this question. Wait, did you go for circle? Okay, but you went for circle, yeah? Ah, no, not too bad. What shapes did you go for? So you went for square, good, okay. And Amanda? No shape. You went for circle. Okay, good. And you went for circle?
No, I made a rectangle. No answer there, but just one.
Okay. Can we go to the next one? Yes? A bolt of lightning strikes a tree 30 centimeters wide and 3 meters tall. How much resistance is there in the tree?
You know the previous question?
Yeah.
If we just don't take it x and x, if we make a rectangle,
Yeah, well then see the problem with that is you have two unknowns.
yeah.
So you couldn't actually finish
No,
it.
we can find the area, the whole total
Yeah.
area. Then we can use the area formula to find 1 because we have the length. 10 centimeters.
No, I don't think this. No, I don't think this would work. I can check it for you, but the problem is you have two unknowns. So you shouldn't be able to get an answer.
The first formula, you know the.
No, but listen. You have two unknowns, so you shouldn't be able to get an answer. So if you did get an answer, it means you did something wrong. I'm telling you this as a fact. So the only way we can do this is if we use a circle or a square because they have only one unknown. If you want to use a rectangle, I must give you one other piece of information. You know what I
We
mean?
have the length of the rectangle.
Which length?
You said this 10 centimeters.
No, that's not the length of the well, that would be the depth if you're drawing it like this. That's what I gave you. I did not give you this or this. Okay. So you don't have enough information. Right. The next one was with the tree. What did I say the height was? I think it was 3 meters. Was that right? Yes? And then 30 centimeters wide. Okay. So, resistance here when the lightning strikes the tree. Rho L over A. I'll have to get the one for wood. The length is 3 and the area is pi or squared. And what's the one for
1
wood?
into
1 times
into
10 power
14.
14. Alright, so probably a huge number. What is it?
4, 2, 4.
Say that again, Grace. 4, 2,
2, 4.
2, 4.
No.
Start again. 4.
4, 2, 4.
Yeah.
3, 2, 8, 1, 4.
Okay.
0.7.
Wait, what?
0.7.
0.71. Okay, alright. So we'll just say that is, let me see.
I
4.
got 3.33 into 14.
That's quite different. Can you retype this in? 1, 2, 3, 1, 2, 3, 4, 5. Four point 2.4. 1, 2, 3, 4, 5, 6, 7.
All this right.
Yeah. 10 power 7 ohms. Or if you want, you can say that's 42.4 mega ohms, if you prefer. Yeah. Okay, next one. telephone company is laying down copper wiring. The copper wire is 4 millimeters in diameter and 2 kilometers long. When the current is running through it, then how much resistance will the copper wire offer? Yeah, let's just say offer. Would two wires which were braided together and not insulated? Okay, the English is messed up there. So for this last one, oops, oh come on.
4 into 7 power.
2 and 4. Hang on a sec. 4. All right. So the first
The answer was 4 into 2,
the last one, 42.4 mega ohms. Okay. For this last one here, you have some copper wire, and it's very long. It is 2,000 meters, and then the diameter. What did I say? 4 millimeters. Yeah. 4 times 10 to the minus 3 meters. So the radius is 2 times 10 to the minus 3 meters. So the resistance, rho L over A, resistance, whatever it is for copper, and then pi or squared. What's the value for copper, KJ? Do you have it there?
1.72 times 10 raised to minus 8.
Okay, so what's the resistance here? Is it?
It's 1.
4
No,
millimeters?
so not the radius, the area. Sorry.
Oh, the area? I don't have the area yet. Pi or squared?
So why it's 2?
Because the diameter was 4, so the radius is 2. See? Diameter was 4, so the radius is 2. What's the or here? KJ, do you have an answer? KJ? Look, your classmates are starting to get impatient. They're starting to calculate themselves. Come on. 2.73 times 10 to the... Oh, just 2.73. Nice. 2.73 ohms. Now, the next question, it was a little bit, not a little bit of a trick, but there is a quick way to do it. In the second half of the question, you have 2 wires braided together. Do you know what braided means?
Yeah,
No?
yeah.
The girl should know what braided means. You know braided?
They make the hair like
When you take your hair and wrap it around? Huh? Like a ponytail, yeah. So these 2 wires are braided together, so it means there's 2 going around like this. Okay?
Even though my area was different, I got the same answer.
For the second part?
No, the first one.
Oh, that's a happy accident then. So they're braided together. So the only difference is when you look at it, there's 2 at the end, and they wrap around. So when you think about it, the only difference is the area is twice as big. Yes? So that means the only difference is this is a 2 here. There's 2 of them. So what would happen to this answer? 2 times bigger or 2 times smaller?
Bigger?
Smaller.
Why smaller? Oh, the area is bigger.
Yeah, yep. So then the or is 1.37? About? Something like this, roughly. So this is part B.
The area or the radius?
The area doubles. It exactly doubles. Think about it, KJ, if I have one circle and then I just double it, make 2 circles. The area has exactly doubled.
How do you call this?
Braided.
Braided.
Braided, yeah. Is that okay?